here and make a video of this course. Okay? You guys should be very grateful because if this had a video, you actually have to join class. Which we know you really don't want to do. Because this is half time. Okay. My half time. And I'll generally put stuff up there every once in a while too. Okay. So if you have any function and you want to take a derivative, you should be able to take a derivative of any function. So the basic thing is if you have some kind of polynomial, remember what you do? I'll use this side. You bring the power in front, and you subtract 1 from the power. And if you had a constant here, you just leave the constant. So for example, remember that? That was the easy one, right? God forbid that was on the fun. So you just bring the power in front, multiply them together, and reduce the power by 1. And of course, you can have a whole chain of these things, like a polynomial. So if you had something like that, like the derivative, none of my f's look the same. You can guess my penmanship grades when I was young. Okay. Bring the 3 in front, and you get 18x squared. Bring the 2 in front, you get 10x. And 4 is a constant, so the derivative of a constant is 0. Okay? That's the first derivative you should make sure you can do. Okay. And then, everybody's favorite derivative, e to the x. Derivative of e to the x is e to the x. Awesome. If you have a constant, it just stays in front. Okay? And then you have the chain rule. So if you had a little erasing, if this is e to the ax, then you can multiply by the derivative of ax times a. Okay? So for example, if you have f of x as 10 e to the 3x, and prime of x would be 10 e to the 3x times 3, also known as 30 e to the 3x. Okay? This should be totally reviewed for you guys. Be nice and easy. Okay, so that's the second one you want to make sure you know. So for antiderivatives, we're moving backwards. Okay. Did you guys get the antiderivatives last semester? You did? Good. So I'll do this as quickly as I can to review. You get outside that snowball fight. No? No snowball fight yesterday? Sad. You busy watching football games? Yeah? Well, one was a good game. The other one was not really much of a game. I will fight that. So, let's see. Other derivatives. Well, let's see. Derivative of sine. Is cosine. And thanks to the chain rule, if the x is multiplied by something, we multiply by a. So if we had f of x with the sine of 3x, and prime of x cosine of 3x times 3. Okay? Nice and easy? Chris, I didn't see you back there. Wow. There's a whole bunch of people over here that I know. I thought you could hide. But you can't just because you're sitting all the way back. Right. Okay, good. And I see better far away than I do up close. Take it easier that way. So derivative of sine is cosine, derivative of cosine is negative sine. So for example, if I had cosine of pi x. By the way, we put pi in problems so that more of you will get them wrong. That's the main reason we use that letter. Okay? As soon as they introduce pi or e or pi and e, I know people are going to go down. Like, oh crap, pi. Alright, so this is minus sine of pi x times the derivative of pi x, which is pi. Okay? Why would I 3 there? It should be an a. Okay. I already posted stuff from last semester, but it should be up again. I may do a new version of it. Why not? See how lazy I'm feeling this week. Okay, so sine and cosine. Then I'm going to go a little faster and go through some more of these. And all of these is the chain rule. And the chain rule is going to be important when you do the antiderivative. So if f of x is tangent of x, f prime of x secant squared x, f of x is cotangent of x, f prime of x minus cosecant squared x. You guys know these? I hope. If f of x is secant of x, f prime of x, secant x tan x, if f of x is cosecant of x, almost done, f prime of x is minus cosecant cotangent of x. Okay, we took care of all the trig ones. We did e. Only a couple left. F of x is natural log of x. F prime of x 1 over x. Did I forget anything? The others I think can wait. You should make sure you memorize all of these. Product rule, quotient rule, don't really worry about that. We're going to work a little bit with the product rule much later, but I wouldn't worry about that for now. Quotient rule, I mean, obviously you need to retain this stuff, especially if you're going to be engineers or physicists or a mathematician. But other than that, it doesn't really show up in this class. This class is a lot of technique of integration, which is what we're going to be starting on in a minute. Okay? And then there's some word problem kind of stuff. Not too much. Some stuff that uses graphs, but you don't have to do graphing. You're supposed to know how to graph by now. I think that's about it. So we keep you pretty busy with techniques of integration. It's a lot harder than it sounds. And of course theory. This theory is very important. You have to know why this stuff is true. Actually, most of you don't care why this stuff is true. Yeah. You're willing to take my word for it. Right? And you don't care if I prove those. Alright. So now, the whole point of antiderivatives is working backwards. Alright. So, derivatives are easy compared to antiderivatives. Right? It's very easy to smash something. It's very hard to unsmash something. Antiderivatives is working backwards. So, when you've got the derivatives, you're now going to go backward and find the original function, which is what we call by technique of integration. You can differentiate just about anything, but you cannot anti-differentiate just about anything. There's lots of functions that do not have an antiderivative. Or if they do, it's extremely difficult to find. So we're going to save the most difficult ones for the midterm and the final and give you the easy ones in class. Right? That's what we do in organic. Any of you taken organic yet? I'm sorry. The rest of you still in like 132 and things like that. Good luck. I never took that stuff. I went straight to physics. And you think chemistry and bio are hard, wait till you take physics. You all got this? Alright. Antiderivative. So now the antiderivative is working backwards. function, and I say this is something's derivative, what's the original function? Why would you want to know the original function? Any ideas? Why would you want to know the original function? Because I'm going to test you on it. Can you think of another reason? Okay, that's the only reason then. I'm not sure what the answer is. Integrals are useful in all sorts of fun stuff. They show up in statistics. They show up in physics, bio, and chemistry. The good news is probably not as much you're going to do, although a few of you will get there. But derivatives find tangent lines, and you figure out how things are changing. Antiderivatives you can now use to find totals. So derivatives you can find, say, how fast the car is moving, and in antiderivative you find out how far it's gone. Those some other things. We'll get to them. So, remember how you took the derivative of x to the n. So now, let's suppose that I know that the derivative of function is x to the n. And I want to find the antiderivative. So I use capital F to say I'm going to go with antiderivative. And apply the word antiderivative to this. Look at that handwriting. Isn't that the handwriting of a C student? I don't know why I got D's and F's. I should have gotten C's. You've got it in counting my grade point. Maybe they don't do grades for handwriting anymore. This is just nothing, right? This is doing nothing. Nothing. Anyway, that says antiderivative. Can't read it. What would the original function have been? Well, what you do is, remember, derivative, you bring the power in front and reduce the power by 1. So for antiderivative, you're going to want to go the other way. You're going to want to increase the power by 1. Divide by the power. So if you take that in your head, and you say, let's take the derivative of that. So that's x to the n plus 1 over n plus 1. We're going to take the derivative of bring the power in front. And I subtract 1 from n plus 1, and I have n. And since this was divided by n plus 1, we now cancel. Look at that, I'm back at x to the n. But as you may have learned last semester, there's more than one function for the antiderivative. So say f(x) is x to the 4th. So what's the antiderivative of x to the 4th? Well, raise the power by 1. Divide by the new power. But here's the problem. If you take the derivative of x to the 5th over 5, you get x to the 4th over 4. That's the 4th. But if you take the derivative of x to the 5 over 5 plus 1, you also get x to the 4th over 4. The derivative of 1 is 0. Okay? And if you had x to the 5th over 5 plus 2, the derivative again is x to the 4th. So every time you take the derivative of any of these functions, you come out x to the 4th. So what do? Because we just want one antiderivative. So what we do is we write plus c. Now, we say c stands for a constant. We don't know what that constant is, but when we take the derivative, we get back to x to the n. Okay? You just don't know what the constant is. So it's in. Am I coming through okay? Shut? Yeah? Udi? Question? No. Can you hear me okay?
Yeah.
All right. So that's why we write plus c, because the derivative of any constant will be 0. So this is what's called an indefinite integral. We're going to get to in a little bit of our classes. But essentially, if we know what a function is, we know what the derivative is precisely. But if we know what a function is, we don't always know what the antiderivative is precisely. We usually need a second piece of information. So if I told you that f of x is x to the 4th, and I want to find the antiderivative, and I told you that the original function has a value of 10 when x is 0, then you would know it's x to the 5th over 5 plus 10. Because now if I plug in 0, this comes out 10. And if I take the derivative of this, I get x to the 4th. Okay? this is the primary one you want to be good at. Let's say, let's do an example up here. I know I'm going kind of fast because this is supposed to be review. So, what would the antiderivative of that be? So I have x cubed plus 4x squared plus 10, which is the antiderivative. Well, do the antiderivative of x cubed, raise the power by 1, get x to the fourth, divide by the new power. Do 4x squared, raise the power by 1, get 4x cubed, divide by the new power. And 10 would be 10x, because what's the derivative of 10x? It's 10, right? And then plus it. Okay? So, one more, just to make sure everybody gets the idea. So there I had square root of x plus x to the fourth plus x to the minus e. And we're going to do the antiderivative. Okay, so for square root of x, and that's the same as x to the half. So if I want to do the antiderivative of x to the half, I have to take a half and add 1 to it, right? So that would become x to the 3 halves divided by 3 halves. And for x to the fourth, that's x to the fifth over 5. And for x to the negative 8, I add 1 to negative 8, I get negative 7, negative 9. So it's x to the negative 7 over negative 7 plus c. Now you can flip that fraction and make that, I'm going to run out of blackboard here, 2/3 x to the 3 halves plus x to the fifth over 5 minus x to the negative 7 over 7 plus c. Hope you guys can see that down there. That is really awful looking. We'll rewrite it. Make sure you're very good at playing with your exponents. Those kinds of things. That is 2/3 x to the 3 halves plus x to the fifth 5 minus x to the minus 7 plus c. Okay? You all understand these? Ask a question if you got it. So far, this should all be reviewed, right? Yes? For me, I consider that fine. I'll have to check with Professor Tanase. Some professors are very fussy about all that simplifying and stuff. I don't think she is, based on my conversations with her, but you never know. Some of the professors say, let's get it all the way cleaned up, they're unhappy. And if they're wrong, they'll be the answer. Okay? So I will certainly fight for that. Other questions? Now, this will be on the insert. I can tell you that now. There will certainly be at least one antiderivative. All right. What if f of x is e to the x? Or e to kx? Remember, when we took the derivative of e to the kx, we had e to the kx times k. So now we have e to the kx divided by k plus a constant. to the 10x over 10. So you kind of do the opposite of what you did with derivatives. So now that you've learned all that derivative stuff, you have to unlearn it and do everything backwards. And this gets very confused in your head, especially with the finance topics. So you have to practice. So when you look at a function to test whether you've actually found the derivative, take the derivative. If you take the derivative of this, as e to the 10x times 10, and the 10 in the denominator cancels that times 10. Okay? Does that make sense? If you're not sure, take the derivative. Make sure that you got the antiderivative correct. What if f of x? Sine of x. What's the derivative of sine?
Cosine.
Cosine. So the antiderivative of sine minus cosine. We look for the plus c's in the exam, by the way. Make sure you put that in there. How about f of x cosine of x? Well, the derivative of cosine was minus sine, so the antiderivative of cosine would be positive sine. Why? Because the derivative of sine is cosine. Okay, so just always remember you're going the other direction. Alright? I'm going to erase that in a minute. Make sure you've all got it perfect. I can't believe you guys all made it back in time for Monday class. It's amazing. There are a lot of emails that said, I'm not coming today. Is that okay? Sure. But when I say no, you have to be here. You made it. Right? You guys all made it. Good. So you should get a bonus point for that. I think so. You're showing up? Sure. Write your name down. Let's see. More functions and integrals. Last semester, the attendance got so bad that I gave the kids who came to the last class a code word, and if they wrote the word on the exam, they got an extra point. Just so you know. So some people were wondering why some kids wrote the word banana on the front page of the exam. Now you know. Never know what I'm up to. Let's see. Okay. F of x is 1 over x, and the antiderivative is natural log of x plus c. Because the derivative of natural log is 1 over x. Not too many more. F of x is secant squared x, then the antiderivative is tan x. Because it's, let's see, because the derivative of tangent is secant squared. Notice, I'm not going to give you tan x, because tan x is the derivative of what function? Not secant squared, it's the other way around. So you have to learn how to find the antiderivative of tangent. It's not as simple. It involves logarithms. Good. Okay. I have to teach you my 126 class in 2 weeks. Isn't it great? You're almost done with logarithms forever. Isn't that good? No more unit circle. Almost. No, still got to know unit circle. A little bit longer. Still got to know sine of pi over 6 is. Pi over 6 is good. What's the sine of pi over 6? Up, like a half. Okay, good. Okay, we'll let it slide. Couple more. Okay, derivative of secant is secant tangent, so the antiderivative of secant tangent is secant. plus c. Okay? Then there were a couple that I skipped a little while ago when I did the derivatives. F of x is 1 over the square root of 1 minus x squared. Okay? So then the original function is arc sine, also known as inverse sine. Okay? Because the derivative of inverse sine is 1 over the square root of 1 minus x squared. Remember this from last semester? That was one of those painful ones. Probably showed up at the final. Inverse trig functions are very useful when you take physics or engineering. Can't think of anywhere else. Not this. I'm not going to hand you a scalpel and say, do an inverse trig function. Not going to. So far, I've been watching Grey's Anatomy faithfully. I've yet to see any inverse trig function. A lot of funky stuff, though. Let's see. How about f of x is 1 over 1 plus x squared. Tan inverse of x. The derivative of arc tan or inverse tan is 1 over 1 plus x squared. We're almost done. Okay, let's do a couple of fun practice problems. We'll make sure we can do it. Okay, so capital F stands for the antiderivative. Find the antiderivative. That's its derivative is x to the 4 minus 4 x 2 plus 6x plus 2. And f at 0 equals 4. Doesn't know how to do this? Did you guys take PC calculator? Why? We're ready for the placement test? Taking it over? Okay. So for most of you, this is new then, right? See, in the fall class, a lot of people are in for PC. That gives them a big advantage over everything else. This was easy. Okay, let's do the antiderivative. So, the antiderivative of x to the 4th is x to the 5th over 5. 4x cubed becomes 4x to the 4th over 4. Okay? And then these 4's are going to cancel. Think about it. Take the derivative of x to the 4th, you get 4x cubed. Okay? For 6x, 6 squared over 2, that's going to reduce to 3x squared. Because if you take the derivative of 3x squared, you get 6x. And the antiderivative of 2x is 2 is 2x. This derivative of 2x is 2. So this is plus c, right? Don't forget the plus c. Now, this helps us figure out what c is. Because now we know what f of x is in general, and we know that when x is 0, e is 4. So you take 4 and you plug it in. Those all come out 0. So those are all 0. You get 4 equals c, and therefore the function is x to the 5th over 5 minus x to the 4th plus 3x squared plus 2x plus 4. Does that make sense? How do you doing now? Nice and easy? Yes. On the exam, you can just go right to where the constant comes. Sure. You don't have to do it plugging in if you don't want to. On the other hand, if you get it wrong, then you don't get the partial credit. So no pressure. Okay. Let's keep it annoying. How do I make it annoying? How do I make it hard? Trig, logarithms, trig and logarithms. Alright, so, capital F. What's the antiderivative of cosine? Sine of x. Antiderivative of 3 to the x is 3 to the x. Plus a constant. And I know when x is 0, I have to get 2. So 2 sine of 0 plus 3e to 0 plus c. Sine of 0 is 0. Good guess. Okay? E to the 0 is 1. This is 2 equals 3 plus c. C is negative 1. And that means f of x is sine x plus 3e to the x minus 1. So far, so good? Really? Happy? Okay, so that's what I was supposed to cover for today, the opening class. So I'll see everybody on Wednesday, which will last longer.